All right, so number one, what would x equal? 3. All right, so 2 to the third power equals 8. Number 2, 4, good. 3 to the fourth is 81. And number 3, 2, good. All right, so those are pretty easy. So when we solve exponential equations, the first thing we want to do is try to see if we can get the bases the same. So in order to solve exponential equations, get the bases the same. And we'll talk about this in a little bit. Because if we can get the bases the same, then there's a property of exponential equations that says if b to the x equals b to the y power, so if the bases are the same, then the exponents must be equal to each other. If the bases are the same, the exponents are equal. So you can see, like on number 1, we have base 2 and base 8. And we could change 8 to base 2 using exponents. We could change it to 2 to the third power. All right. Number 2, you have base 3 and base 81. We could change 81 to base 3, 3 to the fourth power. Same with number 3. We could change 16 to 4 to the second power. All right. So we're trying to get the bases the same if we can. Now, sometimes the bases are already the same. And that's nice, because if the bases are the same, then we can drop the bases, cancel them out, and set the exponents equal to each other. So number 4, when we cancel the 6's out, since they're the same, we can just set the exponents equal and solve for x or whatever variables in the problem. Right? So x equals 1. Number 5, same thing. Bases are the same. Set the exponents equal. Solve for x. All right, now number 6 is multiplying two bases together. So you can't, when there's 3 bases, you can't just cancel all the bases out. So what you have to do is combine the 2 that are being multiplied together first. So we have a property that says when we're multiplying like bases, we can carry the base, keep the base, but add the exponents. Okay, so we can add these exponents together. So this becomes 3 raised to, well, x plus 4 is 2x plus 4 equals 3 to the x minus 10. Right, so we don't multiply the bases together. We keep the base the same, but add the exponents. Right, and then we can just cancel the bases out and set the exponents equal. Right, so what if the bases are not the same? Well, what we want to do is try to get them to be the same. And so a couple techniques is if you have 2 different bases, try to change the big base to a smaller base. You can't change a small base to a bigger one, but you can go big to small using exponents. Also, if there's a fraction base, so if you have a base that's a fraction, then what you want to do is flip it and put a -1 exponent. Because fractional bases are tough for a lot of people to work with. I'm not saying you can't work with them, but for a lot of people it's hard. All right, so on number 7, we have base 3 and base 27. They're different, and so we want to get them to be the same so we can cancel them out. So you can change a big base number to a smaller one. All right, and so try to look at, the smaller one and see if you can make the bigger one that base. All right, so using our exponent sheet, we can see that we can change base 27 to base 3. So 3 to what power is 27? It's 3. So we can rewrite this as 3 to the x plus 4 equals 3 to the third power. Okay, it still has a value of 27. It's just the way it looks is different. So this allows us to get rid of the bases and set the exponents equal. So x equals negative 1. All right, number 8, we have base 32 and base 2. So we can change 32 to a smaller base. So we could use base 2. So 2 to what power? 5. So we have 2 to the 5th raised to the x plus 3 equals 2 raised to the 2x. All right, now, when we have an exponent that's raised to an exponent, we have to use our exponent properties and say we multiply exponents together. So this 5 is going to get distributed to the x and the 5. So be careful there because it's a binomial. So it's 2 to the 5x plus 15 equals 2 to the 2x. Now you cancel your bases out, set the exponents equal, and then solve for x. So when there's a binomial, usually the mistake that's going to occur, I'll just show you, it's going to be because people forget to distribute it over the second term. They'll multiply to the first one, get the 5x here, but then they'll just drop the 3 down. So make sure it gets distributed. All right, number 9. Let's say they're different bases, 8 and 4. So can we change 8 to a base 4? No, there isn't 4 to a power that's ever going to equal 8. So that means we have to change both of them, both bases, 8 and 4, to a smaller one. So that means we have to go smaller than 4. So we want to use base 2. So 2s are going to work a lot, 3s are going to work a lot, 5s, that kind of thing. Small numbers are going to, look for those. So 8 is 2 to the third, to the negative 2x, and 4 is 2 to the second power. All right, so we have 2 to the negative 6x equals 2 squared. By the negative 6, negative 1/3. All right, now number 10, we have base 64 and base 1/8. So this is where when you have a fractional base, is the easiest thing to do is flip it. So that's 8 to the negative 1 power to the x. All right, now I can multiply the negative 1 and the x together. I'm just showing you all these steps. I know some of you are going to, combine steps together. All right, so we have base 64 and base 8. What base can we get them both to be? 8. Okay, so 64 is base 8 to the second power to the x minus 4, 8 to the negative x. We can distribute here. We can cancel the 8's out. Okay, so it's 2x minus 8 equals negative x. All right, so subtract 2x. All right, so we're going to leave it as positive 8/3. So try to leave your answers exact. That means fraction simplified, or decimals are fine as long as the decimal stops. But if it goes all the way across your screen, it's repeating, then convert it back into a fraction. Okay, unless it says go ahead and round it, then give it as exact. All right, number 11, what base can we use? 5. Yeah, you can't use base 25 because you can't change 125 to 25 to a power. It doesn't exist. Right? So you have to use base 5 on both of them. All right, so 5 to the second to the x minus 1, 5 to the third to the 4x. All right, so we're going to distribute the 2 and cancel the bases also. So 2x minus 2 equals 12x. All right, and then go ahead and try number 12. So you have 2 fractional bases.